So, good morning everyone. Good morning, sir. So, today we'll be discussing about the need and functions of an operating system. Anyway, I am Lovely Dean Dorig, along with my co-reporters Agor Elorde and Christian Donde, who will discuss the later parts of the topic. So, let us have a short recall about what is an operating system. So, an operating system is a software that acts as an intermediate between the user and the hardware. It is a kind of resource manager that manages both hardware and software resources of a system. So, there can be various resources present in the system, and to manage it manually is a very difficult task. So, we make the use of an operating system to manage all the resources present in the system. So, what is the goal of an operating system? We have to execute user programs to make tasks easier and efficiency. So, the goal of an operating system is to provide a user-friendly and convenient environment. We know that it is not compulsory to use the operating system, but things become harder when the user has to perform all the process scheduling and converting a user code into machine code, and so that is a very difficult task. So we make the use of an operating system to act as an intermediate between the user and the hardware. So all you need to do is to give commands to the operating system, and the operating system will do the rest for you. So we have also here the efficiency. The goal of an operating system is efficiency. The operating system should perform all the management of resources in such a way that the resources are fully utilized, and no resource should be held idle if some request to that resource is there at that instant of time. So, next. So, operating system acts as a medium between the hardware units and application programs. So, as you can see here in the figure, we have the hardware, which is on the bottom part. So, what are examples of an hardware? We have the CPU, memory, and input-output devices. So, for us to have an access on the hardware, we need the help of an operating system. So to connect with the application programs and system software. So, application softwares or programs is used by users to perform a specific task like MS Word, VLC Media Player, etc. And system software, this software is used to manage the system resources like compiler, assembler, and text editor, and etc. So, the operating system is used for the communication of these softwares with the hardware. So, need for operating system, we have first, operating system as a platform for application programs. Provides a platform on top of which other programs called application programs can run. These application programs help the users to perform a specific task easily. It acts as an interface between the computer and the user. It is designed in such a manner that it operates, controls, and executes various applications on the computer. Second, managing input and output unit. Operating system also allows the computer to manage its own resources such as memory, monitor, keyboard, printer, and etc. Management of these resources is required for effective utilization. The operating system controls the various system input-output resources and allocates them to the users or programs as per their requirements. So, third, consistent user interface. Operating system provides the user with an easy-to-work user interface. So, the user doesn't have to learn a different UI or user interface every time and can focus on the content and be productive as quickly as possible. Operating system provides templates and UI or user interface components to make the working of a computer really easy for the user. So the last, multitasking. Operating system manages memory and allows multiple programs to run in their own space and even communicate with each other through shared memory. Multitasking gives users a good experience as they can perform several tasks on a computer at a time.
Good day everyone, and I am the second reporter. By the way, I am Gordy Lodi, and my topic is all about functions of an operating system. Functions operating system has for management. First, processor management. What is processor management? A process can be thought of as program in execution. A process will need certain resources, such as CPU time, memory, files, and I/O device to accomplish its task. These resources are allocated to the process either when it is created or while it is executing. Processor management keeps track of processor and status of process. The program responsible for this task is known as traffic controller, allocates the processor or CPU to a process. What is the purpose of the processor management? The heart of managing the processor comes down of two related issues, ensuring that each process and application receive enough of the processor's time to function properly, using as many processor cycles as possible for real work. So this deal with the management of the central processing unit or CPU. The operating system takes care of the allotment of CPU time to different processes. When a process finish its CPU processing after executing for the allotted time period, this is what we call scheduling. There are two types of scheduling. First is what we call SJF or shortest job first. The process which needs the shortest CPU time is scheduled first. The second is round-robin scheduling. Each process is assigned a fixed CPU execution time in a cyclic way. Next of the scheduling, priority-based scheduling or non-preemptive. In this scheduling, processes are scheduled according to their priorities. The highest priority process is scheduled first if the priorities of the two processes match, then schedule according to arrival time. Context switching. In most multitask task, tasking OS, multiple running processes on the system may need a change of state in execution. Even if there are multiple processes being executed at any one point in time. So one point in time lagi siya. Only one task is executed in the foreground, while the others are put in the background. So the processes that is in the foreground is determined by the priority-based scheduling, and the OS saves the execution states of the previous process before switching to the current one. This is known as context switching. Next is device management. The operating system communicates with the hardware and the attached device and maintains a balance between them and the CPU. This is all the more important because the CPU processing speed is much higher than that of I/O devices. In order to optimize the CPU time, the operating system employs two techniques, buffering and spooling. Next, buffering. Buffering in this technique, input and output data are temporarily stored in input buffer and output buffer. Once the signal for the input or output is sent to or from the CPU respectively, the operating system through device controller moves data from the input device to the input buffer and from the output buffer to the output device. In the case of input, if the buffer is full, the operating system sends a signal to the program which processes the data stored in the buffer. When the buffer becomes empty, the program informs the operating system which reloads the buffer and the input operating continues. Next is spooling or simultaneous peripheral operation online. This is a device management technique used for processing different tasks on the same input or output device. When there are various users on a network sharing the same resource, then it can be possibility there's a possibility that more than one user might give it a command at the same point in time. So the individual user needs not to wait for the execution process to be completed. Instead, the operating system sends the data from the hard disk to the resource one by one. Example, printer. Third, memory management. In a computer, both the CPU and the I/O device interact with the memory. When a program needs to be executed, it is loaded onto the main memory till execution is completed. Thereafter, that memory space is freed and available to other programs. The common memory management techniques used by the operating system are partitioning and virtual memory. The meaning of partitioning is divided into various partitions of the same size of different size. This helps to accommodate a number of programs in the memory. The partition can be fixed, i.e. remains the same for all the programs in the memory, or variable, i.e. memory is allocated when a program is loaded onto the memory, or it may become fragmented. Last, virtual memory. This is a technique used by the operating systems which allows the user can load programs that are larger than the main memory of the computer. In this technique, the program is executed when it is a computer program can be not loaded inside the main memory, leading to efficient memory utilization. And lastly is the file management. The operating system manages the files, folders, and directory system on a computer. Any data on a computer is stored in the form of files, and the operating system keeps the information about all of them using the file allocated table, or FAT, or a data structure called an inode in Linux. The FAT stores general information about files like file name, type, text or binary, size, starting address, and accessing mode, sequential index, sequential, direct, or related. The file manager of the operating system helps to create, edit, copy, allocate memory to the file, and also update the FAT. The operating system can also take care that files are open with proper access, right to read, and then next is operating system services.
Good day everyone, I am Chrissy Andy Dundee and my topic is all about operating system services or OS services. So the primary function of an OS services or operating system is to provide an environment for program execution and to provide users with a service of how to execute programs in a convenient manner. So, as a result of this, an operating system provides certain services to programs and their users. And there are three common services provided by an operating system. First is the program execution. Second is I/O operations. And third is communication. So, program execution. Operating system provides a convenient environment where users can run their programs. The operating system performs memory allocation to programs, load them into appropriate location so that they can execute. The users not to worry about all these tasks. So, program execution. It handles many kinds of activities from user programs to system programs like printer spooler, name servers, file server, and etc. So the OS loads programs into memory. It also executes the program. It handles the program's execution. It provides a mechanism for process synchronization. And also, it provides a mechanism for process communication. So next is I/O operations. In order to execute a program, it usually requires an I/O operations. Mm, for example, it may need to read a file and print the output. And when all these I/O operations are performed, users cannot control I/O devices. All I/O are performed under the control of operating system. And typical I/O operations are the read or write operations, which are done with the help of output and input devices. So last is the communication. The various processing executing on a system may need to communicate in order to exchange data or information. So operating system provides this communication by using a facility of message passing. In message passing, packets of information are moved between processes by operating system. So two processes may require data to be transferred between the process. So both the processes can be on one computer or a different computer and connected through a computer network. So in addition, there are five of the most common operating system. First is the Microsoft Windows, Apple Mac OS. Third is Linux. Fourth is Android, and fifth is Apple iOS. And that's all.